I'm a security architect in Intuit, working mostly in application security domain, but sometimes I'm crossing the line by going to different areas like infrastructure, networking security, and incident response, mostly to analyze root causes and make sure that we have reliable security architecture patterns to prevent it from happening in the future. I'm also very passionate about security appliances. My first experience with devices like that goes back to 10 years when I was working on a credit card processing solution for a credit card company, and it was Encipher at that time. Then when I joined Washington Mutual, we were building a service-oriented architecture, and I was trying to put security control around it to protect XML traffic using forum system devices. Then when I joined Intuit in 2007, there was yet another interesting project on building a SAA to connect to big medical insurance company. At that time, I was using data power, and again, trying to protect SAA architecture and XML traffic. And lastly, I was involved with Ingrian-related projects to encrypt sensitive data. And the last project was related to Cloud HSM. And I like it a lot, and what I like the most about engineering is that you can play with all those expensive and interesting toys for free and getting paid for that. So this is great. I want Todd, who decided to join me in this presentation, to introduce himself as well, and after that I will go to the talk.
I'm Todd Cignetti with AWS Security. I'm a senior product manager with AWS Security, and my background is developing products and product leadership for a number of encryption, key management, network encryption, file and folder encryption, and full disk encryption going back even further. So those were previous companies. I've been with AWS for 8 months, and Oleg was kind enough to offer to present this topic jointly, and I'm happy to be here.
Thank you. And I think we just will add value if Todd talks about features and architecture and general use cases of Cloud HSM, while I'm going to talk about my personal experience. And by the way, whatever I'm saying here doesn't represent an official point of view into it, or Amazon, or Safenet. All thoughts are mine. Please treat them as such. Let me talk, before I go about my experience, let me talk briefly about a common mindset and mentality, I would say, when it comes to cloud, not to cryptography, but just to the cloud. I think like everybody has agreed lately that in general, any cloud platform that I'm aware of, like Rackspace, App Director from VMware, AWS, is a great tool to enable fast application development. It's very flexible. It allows to build like really scalable and highly available solutions if you do it right. You don't need to wait until hardware is provisioned and installed. You just write the script, you run it in AWS environment, and you have everything up and running. It's even more beneficial when you think about cyclical applications like TurboTax, for example, which has a mini peak in January, then a real big peak, spike in volumes in April, and after that everything becomes very much flat, but we still need to maintain all this expensive hardware infrastructure and so on. So AWS or any other cloud environment is a very good fit for this kind of scenarios. But when it comes to security and privacy, then suddenly the picture becomes not so rosy and not so great. And the reason for that is explained briefly on this slide. So I can rephrase it a little bit. What are people usually concerned about? And it's very serious, actually. Sometimes it culminates in statements that I've heard from executives who were in charge of making decisions about moving or not moving to a cloud. They were saying literally this: I do not want to lose my job because of these issues. So the first thing that we usually consider is that we don't really know what kind of security or privacy policies are implemented by a cloud provider. They are not publicized anywhere. We don't know. The second one, we don't really know who has access to our sensitive data. Can the sensitive data be copied on laptop and then exposed somewhere intentionally or unintentionally. There is no any kind of, usually there is no any kind of legal agreement that would explain what will happen if there is a security breach or if they like can support any kind of SLA. It's not common for scenarios when somebody wants to go to a cloud. And so that's why like people are concerned. And the last but not the least on the list is key management. And there was like a great discussion yesterday in the speed discussion about transparent data encryption, or TDE as Oracle calls it. And if it has value or doesn't have a value. In my view, the value of TDE is not zero, it's more than zero. And I personally would use TDE for less sensitive data. What less sensitive data means depends on your use case, depends on your business. I know what less sensitive data means for small business, for example. I would consider less sensitive data like customer address, telephone name, this kind of stuff. I would use TDE for that. But if you think about more serious data like credit card numbers, social security numbers, keys, passphrases, passwords, banking accounts number, this kind of data I consider as like a real secrets, and I wouldn't recommend TDE for this kind of stuff. Again, my major concern is I don't know how this key management works, how it's implemented by a cloud provider, who has access to key, and so on and so forth. And it's very difficult to change this mentality, and I think this is the major obstacles why companies with like really sensitive data, like big financial institutions, are not going to cloud yet. Because of that, it's my opinion. So if we can change the mentality somehow, at least a little bit, by implementing a very sound data protection mechanism where we control all this key management process and the keys, then I think people would be more comfortable to put their sensitive data to a cloud. And this is why Cloud HSM can help in this task of protecting data better. The major thing that I like about Cloud HSM is that Amazon or any other employee in other solutions that I've seen with this like a rack space, you can implement a solution when cloud provider employees do not have access to your keys. And if you control the key, if you encrypt your data using the key that only you can access, then you have a very high level of assurance that nobody will steal your data or expose it somewhere. Then there are like a number of very good security controls, and Todd will talk about them in details, but I just want to mention that you have at least like 2 levels of controls at network level. The first one is related to security groups, and security groups are just simplified representation on traditional firewall that you can use to protect your Cloud HSM. Then you have certificates that you can install on server and client side, and then use these certificates to establish a trusted communication channel between a client and a server. And finally, at application level, you have 3 levels of credentials. The first one is manager credentials, which can be used to connect to HSM's server through SSH and start doing some kind of management job like initializing the device. And when you initialize device, you will be asked to create administrative credentials. And this is a second level of credentials, which are used to configuring partitions. And important thing here is that you are the one who created administrative credentials, not AWS people. And that's why, like, if you control administrative credentials, it means that nobody else can get access to partition. And partitions are the buckets where all secrets are stored. So the third level of protection is partition level password or PIN, as I call it. And this is what you give to an application that requires access to HSM device to do encryption, create new keys, and so on and so forth. So all these features, I think, make Cloud HSM a perfect tool to bring up assurance level when it comes to protecting data in a cloud environment. And with this, I will hand it over to Todd, and he will talk about, in details about all features which are available at Cloud HSM, and then I will return to my experience.
Thank you. Oleg. So just as a show of hands, get an idea, how many people are really familiar with in-depth what is an HSM? Because I can talk, well, I'd say about half. Great. This slide's going to be a little bit of review, but I want to make sure we hit some of the properties of the HSM are really important to the Cloud HSM service. So let's back up a little bit and talk about what is an HSM. So basically an HSM is a purpose-built appliance that is designed to protect key material and operate with cryptographic operations securely on that key material. It's fundamentally designed so that if tampering is detected, that the HSM will respond and destroy the keys. That's the physical layer of protection, and that's just part of the design. The other part of the design that's critical to the service is the logical separation of roles. And what this means is there's a appliance administrator, and forgive me, but I'm talking primarily about the Safenet Luna SA HSM right now. There are other HSMs that have different security models, different roles, but the intention is the same. But some of the specifics that I'm talking about now are specific to the Safenet HSMs. The roles are, there's an appliance administrator that has the ability to set the network configuration, control syslog, basically treat the appliance as a device in the network and manage it as a normal server would be managed in the network. The other role, though, is much more important, and it's really unique to an HSM, and that's the security officer. The security officer has the ability to control the use of the cryptographic keys that are stored on the appliance. And one way to think about this is the appliance is a one rack unit like a server, right? That's what the appliance administrator can manage. Within that appliance, though, there's a PCI bus and there's a secure card on that PCI bus that is the HSM module itself. And that's where the cryptographic operations occur, and that's where the key material is stored. And that's what the security officer controls. So there's really, if you keep that model in your mind as we talk further, that's really important. Another important factor in the HSM is that it's designed and tested by Safenet to be secure. They have secure manufacturing processes, they have secure development facilities, and they do everything they can to make it secure. But the other thing that they do is they get third-party approvals and validation. So FIPS, common criteria, third-party validations that the device is designed, is built as it was designed to be built securely. So based on that, AWS in March of this year released a service called Cloud HSM. AWS Cloud HSM is the name of the service. What the service entails is dedicated access to a Luna SA HSM. That means the device is dedicated, it's not shared among multiple customers. The HSMs are in AWS data centers, and the advantage of that is you can use the same mechanisms to protect and isolate them within your virtual private network group or your VPC. You can use security groups to isolate them and connect them, but really the idea is that you can connect them to your instances running in AWS. And the latency is minimized because they're located in the same data centers. At launch, we had HSMs in Northern Virginia and in Dublin, Ireland. And what's really fundamental to this service is what I alluded to earlier in terms of the controls and the design of the device, which is physical protection of the secure key material, which is tamper resistance and tamper response. So even though these devices are in AWS data centers, our AWS employees, if there's any attempt to tamper, the device is designed to destroy the key material. Similarly, the device, with logical role separation, we have an appliance administrator role that we can manage the device, connect it in the network, give you access to it from your instances, but you take on the role of the security officer. And that means you initialize the HSM, that little card within the appliance, and once you initialize it with the credentials that you control and we don't have, you own that and you control it. And we don't have access to your key material. If you lose the credentials that give access to the key material, we can't recover it. And that's really a fundamental test of, do we have control of your keys or not? In this case, we don't. So a few more details. I mentioned before that this is based on the Safenet Luna SA HSM. It's a very well-regarded, well-known HSM. It's in use in financial institutions, large enterprises around the world. It's been validated and designed for validation by Common Criteria and FIPS. The other really big benefits of using the Safenet Luna HSM is that it is integrated with third-party applications like Oracle database, transparent data encryption, with Microsoft SQL Server, transparent data encryption. Both of those databases have connectors, essentially, that can, instead of using local software-based wallets, they can use the HSM directly. And those are, both databases come with those packages, and SafeNet provides application notes that describe step-by-step how to integrate them. The other key point, so if you're not using shrink-wrapped or third-party software, if you're building your own application, the SafeNet supports a number of standard libraries that they have modified. Instead of using the local crypto operations in software, they can use the back-end Luna HSM to perform the cryptographic operations. And the standard libraries, PKCS11, Microsoft CAPI, CNG, and Java JCA, JCE. And I have a picture that next shows sort of how you would go about building your own application. But first, a big picture diagram. First, A is, this is what I mentioned. AWS acts as the appliance administrator, but we don't have access to the keys. You are the security officer. You take ownership of the HSM and control the use of the keys that are stored on the HSM. To write an application, you can create an instance in AWS. You can build your application. You use the Safenet HSM client, which establishes a secure connection to the HSM over SSL. And this client, on top of this client, is where these integration libraries exist, PKCS11, JCA, JCE. And these standard libraries makes it easier. So if you're porting an application that uses a software-based crypto library now, it's probably one of those standard libraries. And having the existence of these SafeNet libraries makes it much easier to port your application because of the existence of the libraries. And obviously the back end is, instead software, can now be the HSM itself. And I mentioned before that the HSM is in your virtual private network, your VPC, virtual private cloud, which means you can apply security groups, you can isolate it from the rest of the network, or you can expose it to the degree that you want to by opening it with an internet gateway and open it to the extent that you want to. A couple of the customer applications that we've seen, and this is kind of interesting because when we launched the service, we knew a couple, we had beta customers that were established and that told us, hey, we really like this, we really need it, it makes a big difference. And then we had, we had other conversations and we weren't sure exactly where it was going to go, but over the last several months, we've seen a lot of interesting new applications that have come up. So one of the first was key management for encrypting digital content. That was sort of one we expected. Digital rights management for media, for documents. There's a number of applications that are being built or in operation for DRM. Intersect is a company, a South African company that is using PKI for two-factor authentication, and the Cloud HSM is acting as a root of trust in AWS. It's entirely built in AWS, and the root of trust for that PKI is in AWS on Cloud HSM. There'll be a talk, I think we might be talking about that at reInvent as well. A healthcare portal that uses Oracle database with Cloud HSM storing the master key. Digital signatures for real estate transactions. This is a case where they're using a public CA issued an intermediate signing certificate, but the public CA had the requirement that that signing certificate always remain in a hardware security module. So they were able to meet that requirement and still use AWS with Cloud HSM. Their intermediate signing certificate is in the Cloud HSM, and they're using it to sign real estate transaction documents. And then another application is mobile payments and an e-commerce platform. So it's really been interesting to see the range of applications that have developed. There's more in the pipeline that I haven't even talked about. And so that just gives you an idea. If you want to learn more about Cloud HSM, the link is up there. It's aws.amazon.com/cloudhsm. You're welcome to join us at reInvent. We'll be talking in greater detail. And we have a couple talks about encryption and key management that will go into more depth, specifically about the encryption and key management aspects within AWS. And the security blog at AWS, I think, is a really great source of information about what's happening with security at AWS. So thank you for your attention, and I'll give you back to Oleg. He'll talk more about his explicit experiences with Cloud HSM.
Thank you, Todd. Before I go to this presentation, I just want to recall some conversation that I had with Todd. I was talking about the fact that impressed me the most while I was reading Cloud HSM documentation, and it was a warning. Warning. If you lose your admin level credentials, there is nothing AWS services can do to recover your secrets. And we started discussing it with Todd, and Todd said, oh, we got like reprimanded for that because people were saying, how come you cannot recover? And I said, oh, this is a great security feature. This is what I like the most about your solution. So different kind of point of view, depending on what perspective you have. The process of provisioning is very fast and simple, I would say. It's not completely automated, though. So the first step that you need to do, you would need to fill out some form, and after that, Todd's team will provide manager's credentials for you. And after you have manager's credentials, you will be able to connect using SSH to your HSM server. But it's not all. You still need to do like a few manual steps to make sure that your Cloud HSM can be usable from applications. So first of all, you need to initialize the appliance, and by initializing, I mean that you are going to actually destroy all secrets if there are any, and you would need to create new admin credentials. Then you might want to regenerate server-side certificates, which are used for establishing a trusted connection between client and the server. Then you might need to restart your networking interface using this NTLS bind command. And finally, you need to log in as an administrator to the appliance and do some work on configuring your partitions. So you basically need to create a partition, then you need to register a partition to a client, and this is like yet another good feature, so you can actually assign clients to partitions, and this way you can separate your clients and you can control which client has access to what secrets. And finally, you need to assign a partition to a client. So it's like a little bit of work, and in the end of this presentation, I will show you how it can be automated. There is like yet another interesting problem that I encouraged and that Todd helped me with and Safenet helped me with. It was related to client certificates. So as I mentioned, you do need client certificates to establish a trusted channel between client and the server. And here is a command that would allow you to create a new certificate. After a certificate is created, it needs to be registered. Public portion of the certificate needs to be SCP'd to the server and registered by the server. And normally, to do that, you also need to provide an IP address of the client. Security-wise, this is a very good feature because your certificate becomes bound to an IP. So if somebody compromises the certificates, he won't be able to use it from another IP. And this is security-wise, again, this is good. But if you look at from usability point of view, and if you start looking at auto-scaling groups, then you suddenly realize that there is no such a thing as static IP. Instances go up and down, IP is changing all the time, so it simply doesn't work. And it was actually a question that took some time for Todd and Safenet to answer. But then they finally confirmed that there is a solution, and instead of using an IP, you can simply create a client certificate with a logical name. And you see this on this slide, it's a cert name. And after this logical name is created, again, USCP and public portion of it to Cloud HSM server, and registering, this is the last line of the slide, register the client by certificate name. So it's confirmed, it should work, and I actually tested it, it works as expected. So there is a solution. But of course, there is like security considerations. If you're doing that, then you're compromising security a little bit, because now if client certificate is compromised, it can be used from anywhere. But I think this is like a reasonable compromise, because you can implement other mitigating controls. You probably need to do more scrutiny at network level by carefully considering what kind of policies you want to implement through security groups. And you, of course, need to take care about pins to make sure that they are strong and that they are protected well. So if these two conditions are met, then this compromise with certificate looks like a good one. Yet another good feature that I like about Cloud HSM, I didn't have any problems integrating it with Java client application. It's completely compliant with Java cryptography architecture. So you basically need to do two things. The first one, you need to drop a Luna provider jar file to class span. As a second one, you need to add one line to your java.security file. And after that, you can use standard Java API to do all the traditional cryptography functions like creating symmetric key, encrypting data, decrypting. Everything is done through traditional Java API. Yet another interesting thing is this HA array. HA stands for highly available array of Lunas. And of course, you need to do something like that if you are dealing with mission-critical application and you are concerned about availability of this application. Creating HA array is a very simple task. You basically need to have 2 or more devices which are configured absolutely in the same way. And after this is done, you are using this VTL client-side utility to create a new group using new group key. And then you can add other members to this group using add member. Very simple. After this is done, from application point of view, your HA array looks absolutely the same as a single standalone device. You just need to provide one token which is called slot number or something, and your client will talk to the whole array. And by talking to the whole array, I mean that like if key is created somewhere, it will be replicated to the whole cluster. So if one node goes down, you still will be able to process data. You still will be able to support cryptography for your applications. Now, I want to talk a little bit about suggested architecture. By default, these Luna devices can be created only in VPC. And again, I've heard from operation and from business people, oh, this is not good. we want to have them available from internet. And I was saying, it's a crazy idea to expose this layer to internet. It's a crazy idea. Probably in development in QA you can. No, really think about it. It's like probably more sensitive layers than databases. Do you ever expose your internal database servers on internet? Do you ever make this database server IP external? Never, right? So moreover, even if your database is internal, you're trying to put a lot of protections through firewalls and jump boxes and everything to make sure that even from your corporate network, nobody will be able to access it. So I think when we talk about cryptography and key management, this is even more sensitive than database, and you need to behave well here. And you definitely should not expose this layer on internet. So my advice would be, please keep it in VPC. Please make all addresses private. And if you do need to enable big population of your business server to talk to this layer, use something like proxy layer. And again, you need to have several of them. You probably want to load balance them to make sure that they're highly available and scalable. And on top of that, depending on your use cases, you might want to implement additional security controls on proxies, like two-way SSL, additional authentication, authorization, whatever you want. So I think this is what you need to do. And you see this here, three major security group, red, yellow, and green. And the security group, as I said, is just abstraction of firewall. It's a simplified way of creating firewalls, and you can create network rules and who can connect to whom based on the security groups. So this is an idea. So this is I described a little bit how these groups are defined. There is yet another question that I asked actually Rackspace guys, and there was a very interesting answer that cryptography doesn't solve all your problems. It just moves them to another place. And I couldn't agree more with this, because after you implemented all that, you still need to find a way how you authenticate from your business layer to Cloud HSM, right? And for that, you need to have some secrets. You need to have at least this private client key that I was talking about. You need to have PIN credentials and so on and so forth. So the question is, when your instance starts in a cloud environment, how do you know that this is the right instance? You don't want to put any credentials to AMI, to user data. You don't want to put it even to Amazon S3 buckets, even if they're encrypted, because, as I mentioned before, our mentality is that we do not trust to this out-of-the-box encryption solutions where we do not control the keys. So if you cannot do any of that, then the question is still how you are going to authenticate your instance, which are starting in cloud, and to enable this instance to talk to a Cloud HSM. So the idea here is actually very simple and similar to the situation when you don't have any password or credentials, but you call in somewhere, for example, to your bank and saying, telling them what is your name, where you were born, what is the place of, and they matching all this information using their own database and then making a decision if you are the right person, if they can give you access to your financial data. So the same idea is here. When instance starts in a cloud environment, you can collect a bunch of parameters using metadata HTTP interface. And the parameters that I use in my experiments I enlisted here, but it can be more than that. For example, I've heard about AWS implementing something like private key, which is unique for each instance, right? And then you can use signatures using this private key to authenticate an instance better. It's not in this solution and in these considerations yet, but it can be used. So what I'm trying to say is this is parameters that I used, but you can actually explore and add more to make your solution even more secure. So after a client collected these parameters and sent it to the request, what you can do on server side, for example, server which distributes these initial secrets can be running in your internal data center. You can make a callback using AWS API to AWS environment and fetch the same parameters through API. After you receive these parameters through AWS API, you can do a match. What's coming in request and what API returned, and if these parameters match, if you have 100% match, then this is probably the right instance and you can hand out the parameters. There are like a couple of other features that you might want to consider. You might want to hash all these parameters on server side when you receive them and create a map. So if the same instance will try to initialize itself one more time, it just will return access denied something. This is one-time use policy. Yet another thing that you might want to consider, how long the instance was running. Instance actually needs to be initialized once with this kind of secrets. So when you making a call through AWS API, you are receiving the start date for the instance. So you can check how long this instance was running. For example, if it's like was running more than 5 minutes, again, you can return access denied. So this is like additional security controls that you might want to consider. Now, I think just to make it even more reliable, we probably need to consider authorization as well. Because in your deployment, you might have different types of instances. You might have web servers, you might have application servers, database servers, and all of them might require different kind of secrets. And to make sure that you're not giving all secrets to everyone who is running in your environment, you might want to implement authorization based on IAM roles. Unfortunately, when I started researching it, it was not like that obvious how all these objects, roles, policies, instance profile, and instance are connected. So this is actually how it works. You can create a role, and you can assign a number of policies to this role. And this policy will describe to what resources this role has access to and what kind of access it is. Then you might want to describe your instance profile and assign a role to this profile. And finally, instance profile can be shared between different instances. For example, for all instances running in the same auto-scaling group, you might want to have the same instance profile. For the solution, for the scope of the solution that I was considering, policies are not even necessary here. Because the only thing that you might want to validate on the server is if instance belongs to the role. So fortunately, there is like Java API that allows you to do that. This is like a code that is doing exactly that. It takes instance, object, and role defined as a string and determine if this instance belongs to a role. And again, it was not obvious, it was not described anywhere, so I had to do all this enumeration. My ask to AWS would be, hey guys, since like your reputation is that you have the most comprehensive cloud API, why don't you have a single call, something like is instance and role? This is how it should be, in my view. Because writing all this code, it looks funny. And it's not obvious at all. Finally, I want to talk a little bit about automation. So in the previous slide, I showed you all these manual steps. And it can be annoying, especially if you consider that cloud usually assumes a great deal of automation. So you might want to automate the process of configuring Luna devices, Luna partition, and Luna HA arrays as well. I created a tool which I call Luna Mac, and it's publicly available at this URL, sfnet.p/p/lunamac. And it's kind of experimental, but I use this MVP approach when implemented it, and MVP, for those who doesn't know, means minimal viable product. So I had this like 3 major use cases when I needed to create a single partition on an existing Luna device, standalone Luna device, or an array of Lunas. And I tested it, it works well, and you can play with that if you want to implement any solution in Cloud HSM, and it really helps and avoids a lot of manual work and mistakes, which are usually coming with this. So the only thing that you would need to do to use this tool is to create a JSON file, and this is how it looks like. In this JSON file, you would need to describe a number of objects that you want to create. So you have partitions here, you have Luna devices, and you have arrays of Luna devices. After this JSON is created, you just run the tool, and you have all your Cloud HSM devices and clients configured. There is like a little bit of trick there, because sometimes when you work with Cloud HSM manually, it will ask you to confirm certain operations, like do I really want to initialize HSM or something like that. And for that, I had to do a little bit of screen scraping. I actually was trying to get this output from Cloud HSM, and that's why you have parameters here like input prompt, finish prompt, things like that, confirm word, things like that. And sometimes you just need to type manually proceed or something like that. So all of that is addressed in the scope of this tool. It worked for the cases that I described. I don't know about any other cases, so you can try and let me know. So I think this is what I wanted to talk about today. And the conclusion that I would make from all of this is that if you have really sensitive data, like I described in the very beginning, like real secrets, like password, passphrases, keys, credit card numbers, banking accounts number, then you probably should consider using Cloud HSM as your data protection solution. So you'll have a lot of fun, and probably you will change this common "we do not trust them" mindset, at least a little bit. Probably you're not going to resolve all issues which are related to legal agreements, legal obligations, SLAs. It's not going to help with this, but data protection should be addressed here at very high level of assurance.